should have got that. Okay, cool. Okay, so we were doing yesterday scheduled at fixed rate. Okay. So schedule at fixed rate. Now, what this means is, so this is EX12. All right, it's on the screen. Now, so now the way this works is, so task one. Now, schedulers. Let's put this in here just to make sure. Right. So schedule at fixed rate. I didn't say this yesterday. This can only take a runnable. It can't take a submit. All right. So there's another one called the schedule at fixed rate, and there's going to be a new one as well. It's called schedule at fixed delay. Okay. So when you have a schedule at fixed rate, that can only be a runnable. Okay. It can't take a, what's the other one? What's the other one? Runnable, and what's the other one? Callable. Yes, callable. Okay. So it can only take a runnable. It can't take a callable. Now, what this means it's 5 seconds of a lead in. That's basically what it means. Okay. So if a previous thread is running, it's going to give 5 seconds. Okay. Then every 2 seconds, it's going to implement. All right. Now, it will keep doing this. So now I have down here in the try catch block, it's only going to go for 15 seconds in total. Now, what that means is that includes the 5 second lead in. All right. So that means that this will only actually implement for 10 seconds. The first 5 seconds, it's going to wait while any other threads are doing whatever they have to do. Okay. So if you have a previous thread, it's going to wait 5 seconds. Okay. Wait 5 seconds. And then every 2 seconds, it's going to print out runnable task 1 is time is local time dot now. So I'm going to run that. So this is before our thread runs. It takes 5 seconds before it goes. Yep. It's going 2 seconds, 2 seconds, 2 seconds, and it finishes. Okay. So what it's doing there is, so we look at the times. Okay. All right, so it starts at, so before our thread runs, okay? Oops, screens are working, a minute. Drink, that's the... Okay, now, so that is that guy. Okay, so that's the system thread. All right. So that's the system thread. Now, what happens is that the system thread goes to sleep for 15 seconds. Do we all understand that? Yeah? Because that system thread, and this is the system thread. All right? So the system thread goes to sleep for 15 seconds. Okay? Now, before it goes to sleep, it does this guy basically. Okay? So, this thread will not start until 5 seconds after that time. All right? So, this is 10:58:18. So it starts 5 seconds after that. Now it's actually 24. So it's 58:24. Okay, which is about right, because if you see 962, it's always going to be approximate. It's not going to be exact. Do you understand that? Because it's time. Time is very hard to be exact. So that's the 5 second lead in. So our first thread starts at 58:24 seconds. So it keeps going on to 26, it keeps going on to 28, it goes on to 30 and to 32. Okay, now it goes for 15 seconds in total. So it started at 18 seconds. 18 plus 15 is not exactly 50. It's not exactly 15 seconds, but it's pretty close to it. Okay, so it's always going to be there or thereabouts. It's not going to be exactly 15 seconds. Do we understand that? Yes? So it's not going to be exactly 15 seconds. So so 5 seconds is going to be lead in time. So it's only going to go do its stuff for 10 seconds. Okay, so it goes from 24 to 34, which is 10 seconds. Yes? Now it's 18 to 24. It's 5.5 seconds, but it's thereabouts. Okay, so it's not going to be exact. Now, so this will only run for 10 seconds. If I want this thread to run continuously, while my app is running, I want this thread to run. Okay? All you need to do is take out the services shutdown. Okay? Now, this guy here doesn't really matter. You can leave him in there or not, but it will do every 2 seconds. Watch it. Time at start is 11:02:48. 5 seconds of a lead in. 53, 55, 57, 59, 01, 03, 05, 07, and it keeps going on and on and on and on and on. Okay, so it's relatively easy to get a thread running the whole time by using these schedulers. Yes? So if you have a scheduler, schedule at fixed rate, for instance, it's going to be running continuously in the background. All right. Now, how would you shut it down? Previously, at the very top, we had a static method to shut it down. All right. So you're obviously going to have, if you're closing your app, you're going to have a method called close. All right. And inside that method, close, you're also going to shut down all your services or shut down this service. That's the way it works. Yes? So that's how you get a thread. Now, you don't need this guy. It doesn't matter. All that does is it puts the system thread to sleep for 15 minutes at the start of this. That's all it does. It puts the system thread to sleep for 15 seconds when this guy starts. So it goes for 5 seconds. Then it does approximately 10 seconds worth of that task. And then the system thread is live again. It wakes up. All right. It doesn't have an effect on this, but it can have an effect if you have some other operations there operating the system thread. So if you want a thread to run continuously, you just don't shut down the thread. Schedule thread until you close the app. Okay, so comment out this to see the thread runs continuously. Now I'm going to stop it. There it is. So it just keeps on running. So now what sort of thread would you need running continuously? Security. Yep.
So I thought you start running the tests and first and then call sleep on the system.
Right. So
or like I just thought that might be
the order is here, right?
Yeah,
So this is the system thread. This is the system thread. This is the system thread. Okay. Now this is the system thread. Okay. So this guy runs at basically the same time as this guy. But before it puts itself to sleep, it'll run that. That's the order. Because the system thread is what runs your threads. Okay? So it's relatively easy to get threads running continuously. All right? I'm only putting them in finally because we want to see them shut down. But in reality, different sorts of threads are going to be doing different things. If you have a thread that's creating a GUI, then you might want to shut that down. Your GUI is created, you don't need to do any more. Okay? Now, you've got to determine, are you going to create your GUI? Are you going to create all of your screens and then shut down your thread? Or are you going to create your screens on the fly? What do I mean by that? Your initial screen is only created, and then your thread is, as you click on a button, it's creating the screens for you. All right? Now that would be probably slower, but if it's creating screens for you, you can create a screen that's made for you and you alone. All right? So this thread is going to run for 15 seconds. If you want to get it to run continuously, just don't shut it down. Simple as that. Okay? Because that's the thing about these scheduled at fixed rate, and the next one we're going to do is scheduled at fixed delay. They will keep on going until you shut them down. Is that okay? Is everyone okay with that? Yes? Yeah. Right. Now, there's one other thing as well here. You need to be careful when you're using, so remember that this is a service, okay? So you can add schedulers to it. You can schedule, you can execute, you can schedule at fixed rate, and the next one we're going to do, you can schedule with fixed delay. All right, you can all mix and match, but you need to be careful. So watch what happens. So this is a task, and this guy is another task. All right, watch what happens when I run it. Now the second task just prints off our second task. See? Because there's a 5-second lead into that. And in that 5-second lead in, that runs. So if you have other tasks along with the schedule at fixed rate, you need to be, it can be often difficult to see when they're going to run. Okay, that will run before any of that. Why? Because there's 5-second lead in time, and in that 5-second lead in time, that task has been done. Okay, so I'll put this in here. This will run before the above, as the above task waits 5 seconds. And in that 5-second period, this task completes. Simple as that. Okay, so order tasks can be difficult enough to see. All right, now that is scheduled at fixed rate. Now, scheduled at fixed rate doesn't give a shit about any other tasks in the thread. Okay, if the other task isn't finished by that 5-second lead in, it's going to continue. Doesn't care. All right. So this scheduled at fixed rate doesn't care about previous tasks. All right. The next one I'm going to show you does care about previous tasks. All right. So this is going to be static void EX13. All right. So we're going to start from scratch with this one. So I want to get the time before we start anything. Before any tasks, time is local time.now. And then I'm going to go, so it's the same as this guy up here. Scheduled executor service is equal to new single thread scheduled executor. Jesus. Just take this one out of the way for now. All right. Now, these scheduled executor services can only take runnables. Okay? Can only take runnables. So I'm going to create a runnable task here. I'm going to call it task 1. Is equal to, so now, so what I'm going to do is inside here, I'm going to create a set of 20,000 double numbers. Okay, I'm going to create a set of 20,000 double numbers. So I'm going to take the time before I create. So before set creation time is, I go local time.now. So I'm going to create, what am I going to create? I'm going to create a set of doubles. I'm going to call it do set is equal to stream dot generate. And we're going to supplier. So it's just going to be math dot random. I'm going to limit it. I'm going to limit it to 20,000. And I'm going to save it to a set. So you should be getting used to streams by now. Okay. Very easy to do. Okay. You're creating 20,000. So that's a set of 20,000 doubles. So that's going to take a set amount of time. It's going to take a second or so. All right. And we're going to say after set creation time is plus local time dot now. Now, so let's see, do I have it here? So that's our task. All right. Now, this one we're going to use service dot schedule with fixed delay. So this is another scheduler. Scheduled fixed delay. What we're going to do, we're going to do task 1. I'm going to push an initial delay of 0. Okay, so if a thread is running before it, it's not going to give any thread is running before it. As soon as the thread, now the difference with this one is, as soon as it, if there's a task before it, the task before it has to finish first before this will start. Okay, that's the main difference with this one. So if there's a task before it, the task before it has to finish, and then this will start. Okay, and what delay do you want between each these tasks? We're going to say 2. What are we going to say? We're going to say time unit dot seconds. Now, if I just run that as is, that's EX13. Now, what it's doing is every 2 seconds, so blah, 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 off it goes. So it's going to keep on doing it. Now we'll have a look at it. So before any test, time is, so we'll see that the time, now yours is going to be slightly different, obviously enough. It's going to be, so it starts at 11:16. So this is before our thread starts. 11:16. 50. Okay. Now, it takes, to start off with, so we can see that the first task starts at almost approximately the same time. See that? So the first task starts at 11:16:50 and 173 nanoseconds, which is a billionth of a second. So that's when the system thread, okay? That's the last task on the system thread. Now the first task on this thread is 11:16:50 and 266 nanoseconds. So they both practically start at the same time. Yes? So the system thread, and this is our own thread. The last thread on the system thread and the last task on the system thread and the first task on our own thread execute at the same time. Okay? Now, right. So, that's in right. Let me just have a look, see. So the initial delay is set to 0. All right. So the initial delay is set to 0. And what that means is that as soon as the previous thread has done its work, it's going to execute. Now, that has the upshot that they both basically execute at the same time. All right. So we can see here, before set creation, after set creation, it only takes, to create 20,000 doubles, takes 32 nanoseconds. It has created 20,000 doubles in 22 nanoseconds. Then it goes 2 seconds and it does the next task. Okay, here it takes 6 nanoseconds, which is fucking nothing. It just shows you how powerful modern machines are. It waits another 2 seconds, then it does another task. It waits another 2 seconds, then it does another task. It waits another 2 seconds, and then it does another task. So let's say if we want, we're going to increase this. All right, we're going to increase this to 20 million doubles. Now this might take a second or two. All right, we'll see how does this work. Jesus. Okay. That's taking an awful long time. Right, so I will take that out. And I will change that to 2 million doubles. Let's see how that works. All right, so I'll stop that. So what it's before set creation, it's 11, 21, 30, not 36. Okay, so that is the system thread. This is our own thread. So it starts at 11, 21, 30, 8, 5, 3. Okay, hold on a minute, that's wrong. Hold on. Yeah, 8, 5, 3. All right. Now, then it waits 2 seconds, which is this one here. And before it creates the set, after it creates the set, before it creates the set, after it creates the set. Some of them are taking a second, but between each one of the tasks is 2 seconds no matter what. Do we see that? Between each of the tasks, it's 2 seconds. If I increase this to, let's say, 10 million. Let's just see. Now, it might take longer on your machines there.
Fitting in contact extension 1811. That's John. Fitting in contact extension 1811. Thank you.
All right, so here. Now, so the start time is, so this is 11, 23, 04, 258. Okay, now the task itself starts at 11. So this is system, this is T1. The first task starts at 11, 23, 04, 359. All right, now it takes 4 seconds for that task to complete, because if we get 11, 23, 08, 716. Okay. And we can see that the next task starts 2 seconds after it. Okay, the next time it takes 8 seconds to create the set, but the next task is 2 seconds after that. All right, so this scheduled with fixed delay, it waits until the previous task is finished to start executing. The other one doesn't. That is the difference between scheduled with fixed delay and what's the other one called? The other one is called scheduled at fixed rate. Okay, so scheduled with fixed delay, it's going to run the task. It's going to start it at the initial task. The very first task is going to start basically at the same time as the previous thread, right? So, but from that point onwards, it's going to finish the previous task and then give a 2 second delay. All right, so I'll put that in again. So the comment is here. So each of these tasks will only start after the previous task has been finished and will give a 2 second delay after previous task has been finished. Okay. The very first task in this thread, the very first task, sorry, in this service will start immediately after the previous task. Okay. Now, if you had a task, if we had another task on that service, the first task on this and the previous task on the service would basically start at the same time. If you have a delay of 0, that means basically they start at the same time, practically, because we can see up here at the very top, 04258, 04359. That's only a difference of 1 nanosecond. That's 1 billionth of a second. So what that basically means is that, so I'll take everything out here, is that that guy executes at the same time as that guy. Okay, they're on 2 different threads, but they're basically running at the same time. That's because I set the delay, the initial delay, to be a 0. But the beauty of this guy is it won't do the next task until the previous task is finished. So all the tasks within that, it won't do current task until the previous task is finished, and then it gives a 2 second delay. Now, just like the other scheduled delay, you can set it to only go a set amount of time. So if I don't have any finally, or if I don't have a time unit seconds dot sleep, it'll go on infinitely. So without a time unit dot seconds dot sleep, this will continue infinitely, or until you shut down your app. Okay, so what we're going to do is, yeah.
You put any type of system printout there, you know, that involves the
Yeah.
system thread.
Yeah.
Would that come in the middle of it and all that? When it's printing off, would it be
We'll
off?
see. So this is system thread 1, and we'll say system goes before it. All right, because goes before it because your system thread is running alongside it. All right, so it'll wait 2 seconds, and in that 2 seconds, those 2 lines will execute. All right, now I'm going to, but we're going to sleep this. So I go try, and I am going to go time unit dot seconds dot sleep, and we're going to sleep it for 18 seconds. E. E. Finally, if server start is shut down, so if it's not shut down, we shut down. Now, so what this is going to do now, how this works is, so we have our system thread and we have our own thread. Okay, so this is the system thread. So S, this is system thread S. This is system thread S. Actually, this is the system thread as well. Now, this is our own thread. Okay, so that's the first thing to run. Now, system thread S. Now, this is a system thread. So what's actually happening there is that by the time it gets to there, this has already been run, right? So our own thread is running, but the system thread is put to sleep. Okay, the system thread is put to sleep. So it does its thing. By the time it wakes up, this has done 18 seconds worth of work, yes? But the first thing that happens inside the system thread is we have a final. Okay, because as soon as it wakes up, it shuts down the service. That's the first thing it does. So that's how that works. Do you understand that? Right. Now, so I'll run it. So you'll get 18 seconds worth of work, which won't be a lot. Might run once or twice. Now I should put in here, it's still going. Right, I should put in here as well a print statement. So we know when it's finished. I'll run it once more. So it goes 391, 46, 50. So it finishes at 50. That's right, 32. 18 plus 32 is 50. Okay? Now, these are all fine and dandy and everything. However, there is a problem with them, right? The main problem is if anything happens within any of these tasks, all right, if an exception happens, an interrupted exception can happen in these. All right. If an exception happens inside one of these tests, so they could be running 50 times, it could be running forever. Now, if an exception happens within one of these tasks, they're a suppressed exception. Remember suppressed exceptions? These are exceptions that are, you don't know that have happened. So if you're using these guys, and if you're using a timeout, not only do you have to catch exceptions, you have to catch suppressed exceptions, which is like this. So I'm going to use a stream to get all the suppressed exceptions. So the issue with these is that if exceptions are generated during any of these tasks, let's say this produces this produces 50 tasks. Okay, so the timeout is in such that it produces 50 tasks. All right, so 50 tasks. The exception generated during any one of the tests, let's say this produces 50 tasks, and task 25 produces a interrupted exception. Okay, and task 25 produces an interrupted exception. This will be a suppressed exception. Suppressed exception is basically an exception that's not picked up by us. All right, keeps on doing its thing, and they're hard to spot. So how do we get a suppressed exception? So I want to get all of the exceptions. So I am going to use streams for it. Arrays dot as list. So I'll do this. So what does E contain? E not alone contains the primary exception. It contains an array of suppressed exceptions. So put in here. E not only contains the primary exception, but also an array of suppressed exceptions if they exist.
So are they exceptions that follow on from the
Yeah.
main exception?
Yeah. Well, no, well, no, it's not so much that they follow on from the main exception. It's that if you remember from the try block, you can have multiple exceptions in it, and it's going to be the last exception generated. Remember that?
It'll only catch one of those.
It'll only catch one exception.
The multiple exceptions.
Yeah. So it'll only catch one exception, because that's all that this can do. So if there's multiple exceptions in it, they're going to be suppressed. Simple as that. Okay. So how do you get all the exceptions? It's simply, it's E dot get suppressed. Okay. Because arrays, if they exist. So this is an array of type throwable. All right. So I'm going to print off all the exceptions by using a stream. So I go E dot get suppressed. So E dot get suppressed produces an array of, hold on a minute, that's wrong now. Just a second. So E dot get suppressed, that's an array of throwables. Okay, so arrays as list, that's a list. Then I go dot stream dot for each now. So that's a list. We create a stream from the list and then we print them off. So arrays as list takes an array and converts it into a list. So a simple way to convert an array to a stream is put it inside an arrays as list. So arrays as list, e dot gets suppressed, stream dot for each. That'll print off any throwables we have. Okay. Now you wouldn't have this in your final production of your code, by the way. You only put this in when you're checking to make sure no exceptions have been generated. Or if you're doing a scheduled fixed delay and your first task produces a number that your second task is going to take. Your third task takes the number from, so your second task produces a number that your third task is going to take. Your fourth task takes a number from your fourth task takes a number that your third task has produced. So you're talking about running total. Something that's happening each time is taking something from the previous test. All right, so this can produce suppressed exceptions. All right, so you should, now you don't have to have this in your final production code, but you should always test for them to see is there any suppressed exceptions being generated. Is that okay?
What is that line?
Which line?
E gets suppressed. What does that print out?
That's not going to print off anything if we don't have suppressed exceptions. So
if you did,
it'll print them off. Okay. And if you see yourself getting suppressed exceptions, then you need to go back to see why they're being produced. Okay. So you might necessarily have these in your final production code, but when you're testing your code, you would have it. Okay. That's called white box testing. Yeah. White box testing is testing your code. Black box testing is just testing your inputs and your outputs. That's what black box is. Okay. Now, so we're not going to get this finished today, so I will do a bit of it anyway. So finally, now, so the next one is going to be EX14. Now, this one here is increasing concordancy with pools. Now, so we've been going along here and we've been using single threads at a time. All right. So when I go up here, that's one thread, right? And the tasks are usually in order, but you're not guaranteed, right? So when you have a single thread, your tasks are usually going to be in order, but you always want to check. How did I get it yesterday of all the tasks running together at the same time? Forget how I did it. Let's see. Oh yeah. No, what I did was, if I go for int 5 is equal to 0, I is less than 5, I plus plus. If I just plug in so if I just use schedule, right? If I use schedule inside a loop, all 5 tasks are going to run at the same time. Okay. If I use a schedule inside a loop without a sleep, they're going to run at the same time. All right. So if you schedule inside a loop without sleep, they're going to run at the same time. All right. Now, your task scheduler, which is the thing which is a service that runs in the background, it's also another thread, by the way. So there is another thread running there it's called your task scheduler, which is itself a thread. What that does, that schedules your task. Now, usually it can put them one after another. However, if you go service.schedule, and that's inside a loop, and you have no sleep, all your tasks come to run together at the same time.
Finnegan, contact extension 1811. That's John Finnegan, extension 1811. Thank you.
That's why they say you can't guarantee your tasks are going to run in the correct order, right? So don't be relying on this. Don't be relying on the task scheduler to absolutely positively run all your tasks in the correct order. Always check. All right. Now, if you have, so we see schedule with, how was this one? This is the schedule at fixed rate, which doesn't care whether the previous service or where the previous task is finished or not. Then we have schedule with fixed delay. That will only start the next task before the previous task is finished. Okay. Now, these guys. So, increasing concurrency with pools. These are basically multi-threaded. All right. Instead of dealing with just one thread, you're dealing with multiple threads. Now, the advantage of this is, so you have 4 threads. If you have a thread pool of 4 threads, those 4 threads are going to run at the same time. Do we understand that? Yes? Up until now, we basically had different threads and we want them to run one after another, basically. Here, we're going to have threads that are going to be running at the same time. All right? And how we accomplish that is through something called a thread pool. All right? Now, you can try to manage it yourself by creating 4 separate threads, but sweet Jesus, it gets awfully complicated. All right? So a way around of managing multiple threads is to use these thread pools. Now, what is a thread pool? So a thread pool is a group of I don't know how to pronounce this word, instantiable, instantiable, or would it be instantiate? I don't know. So they're there, it's like the scaffold is there, but we haven't built them. It's a group of pre-instantiated reusable threads that can be used to perform any set of arbitrary tasks. Now, we're all familiar with the string pool. All right, so what's a string pool? String pool is if you create a string, let's say I create the word cat, and I create the word dog, okay? Now, if I create another word cat, the first thing it does is it checks the pool to see does it exist, all right? So if I go string str is equal to cat, and I go string str2 is equal to cat, and if I go str equals if I go str dot equals str2, it's going to return true, okay? Because they are the same object. Yes? Right. Now, we can imagine that in Java, there is a pre-existing pool. All right. Now, I believe you can change the size of this pool. And this is not a string pool. It's a thread pool. Okay. It's a thread pool. Now, so every time you fire up any application that's going to be using Java, your SDK has a few threads you can use in the background. Okay, they're basically empty threads. They're not, don't have any tasks on them. So they're in here. Now I don't know how many are there. I presume there'll be, I don't know, maybe 100, who knows? Right? So there's a set amount of basically blank threads in a pool that haven't been acted upon, that are not doing anything. And what these pools, you can then use these threads in groups. Okay? Rather than creating your own threads and trying to manage them, you're going to use one of these pre-existing thread. What would it be? Exactly. That's it.
That would be like the schedule.
Yeah. No, schedule is a method. These are actual threads. Okay? So it's like when we do this, we are creating a thread in the background that we're going to manage through this object here called service, right? When we use thread pools, we're not actually creating threads. We're using threads that is used that are prepackaged in the background Iggy, okay? So we're using something that's already there. So we don't have to create them. We don't have to manage them either, because they're already there, they're already being managed by Java itself. Okay, now you can create all your own threads and try to manage them, but it's a pain in the arse. All right, so there's a group of pre-reusable threads that can be used to perform any set of arbitrary tasks. Now, there is 3 basic types of thread pools. Okay, so up to this, we'll be dealing with 1 thread at a time. These have multiple threads, 3 different types. There's a new cached thread pool. There's a new fixed thread pool. And what new fixed thread pool takes, this takes the amount of threads you want to use. Okay. And there's lastly, there's a new scheduled. So the first 2 are for single threads, multiple single threads. The last one is for multiple scheduled threads. And that takes the amount of threads you want. Okay. Now, so here we go. Whereas a single thread executor will usually, but not always, wait until a thread is ready to execute a task. A pooled thread can execute the next task at the same time, concurrently. Now, what do I mean by that? You have set up a multi-threaded, okay? So you have a series of 10 tasks and you've divided them up amongst 3 threads. Fuck you. Hold on. So this is T1, this is T2, this is T3. All right, and you have, let's say, 50 tasks. Now, rather than having 1 line of control, you have 3 lines of control. And what can happen here is that T1 will be doing task 1 at the same, and T2 will be doing task 2, and T3 will be doing task 3 all at the same time. Okay? So if it's just pure processing, if you have a really complicated problem, that doesn't matter in what order things are done, you can have 3 threads. And it can take all those 50 tasks. So rather than 1 thread working on it, you have 3 threads working on it. Now, obviously, that's going to cause issues, but that's the basic principle of what we're talking about here. It's a multi-threaded application. All right? Right. So, whereas a single thread will usually, but not always, wait until that thread is ready to execute a task, a pool thread can execute the next task at the same time. Now, right, so I'm going to create one. Now, that's all I'm going to have time to do today, but I'll just create one, and we get one running. Okay, so we're going back to Executor service again. So it's not a scheduled Executor service. This is just an Executor service. So Executor service is equal to Executor. Sorry, it's Executor service is equal to, first one we're going to use is a new cached pool.
Yeah, give it a name there.
Yeah, you're right, Kieran, I do. All right, so now this is the simplest one. It's also the one you shouldn't use. All right, because you have utter chaos. You assign 50 tasks to it, and they can be done in any fucking order possible. All right, so I'm going to put in a try, and I'm going to put in a few services, a few tasks, and we're going to see the order they're going to be run. Is that okay? Right, so I'm going to go try, I'm going to go catch, and I'll do a finally. And if shut down, right. Now, so this is our service. So inside here, now this Executor service can take a callable. So you can have execute or you can have submit. So I'm going to go service dot submit. I'm going to give it a runnable to start off with. And I'm just going to say, just have a print statement. And I'm going to say runnable task 1. Oops. And another one. I'm going to do a submit. I'll have that as the second one. So runnable tasks 2. I'm going to do a submit before that. Service.submit. I'm going to have a callable inside this one. So it's going to return something. So I am just going to have int I is equal to 0 for int. So for I is equal to 0, I is less than 5,000, I plus plus. And I just do a little calculation inside it. I is equal to I plus I. Doesn't matter what it's doing. And after the for loop, we're going to say I is plus I, null. Outside of that as well, I'm going to say int count is equal, or sorry, count is equal to 0. We have a static variable called count. I put in one more service. So service dot execute. I'm going to put in a runnable. I'm going to say runnable task 3, and I'm going to put in here plus plus count, and I'm going to put plus plus count in here, plus 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 count, and I'm going to put plus plus count in here. And in this one, I'll say submit task. Now, we'll do out this, and you'll see it's all over the shop. Okay. Now it's literally all, and when I mean all over the shop, I mean all over the shop. So this is a new cached pool. So that means that all 3 of these LEDs can run together. All right. These LEDs do run together. They do run concurrently. There's no shilly-shallying waiting around here. Right. So this is EX14. Okay, it does actually run a kind of increasing concurrency with pools. So submit task 1, I is 8191, prints off 1. Runnable task 2, runnable task 3. Okay, it's printing in order, unfortunately. Try and run it again. No, bollocks. Oh, fuck it. Okay. Well, it's not working out the way it should be working out, okay? It should be all over the place. Try change this one to a callable maybe. Change it to 50,000. Try to, that is, it's 5 million. No, shite. Fuck it, fuck it, fuck it, fuck it, fuck it. Why is it doing that? Vulnerable task 2, vulnerable task 3. Yeah, I have another example here, and it's doing what it's supposed to be. For some reason, it's not doing it here. Anyway, this is as good a time as any to finish today. All right. What I will do is I'll put the code up for the rest of this chapter, and you can have a look at it if you want. All right. So I do have, but I will start from this point tomorrow week. But I will put the rest of the code up, and you can have a look at it. All right. Now, I said I'd ask you to have a look at Azure. So I still want you to look at it. So I'm just going to bring it up here. So it's your Azure portal is what you log on to. It's Azure.portal. It should log on. It should log you on there automatically to your Azure account. Oh, I don't want to do that. Would you bring me to my fucking Azure account? Azure portal login. Sign into Azure. So I'll sign into mine here. That's me. Now I set up two-step verification. So that means it asks me to log in before. So it's coming up there on my phone. So I log in through my phone. You're logged in automatically there, which isn't such a good thing really, actually, when I think of it. So this is your Azure. Then you log on to your portal. And you have this guy. Okay. So these are all the services. So you click on the top left-hand corner, you go to services. Now, I genuinely don't know what we need to use. That is the big problem here. All right. There is shitloads of stuff. There's literally thousands of services there, because each one of those services is going to have other services. So
Wouldn't the most important one be the one that you have a teacher? Virtual machine app service for the process of
possibly, yeah. Well, all right. So we're definitely going to want some form of database. Okay. So I can have a look at database, right? So that's fine. Now, because I did a quick Google search there of what do you need from Azure to manufacture apps. Virtually all of the returns in Google are Microsoft sites. So they're not going to be honest. They're just trying to sell you stuff.
It's all about, you need to know what you're up to doing first.
Yeah. Well, but I'm saying, like, there's a lot of stuff here that we're not going to need. The vast majority of stuff we're not going to need. Okay. A virtual machine would be useful. Okay. They are exactly as it says in the tin. They're a machine. They're a fully working machine, except it's in a virtual environment. Another screen will pop up here, and it'll operate the exact same as another machine. Now you can tailor those machines to be, let's say, I want a machine with 128 gigabytes of RAM, 2 terabytes of a hard drive, so on and so forth. Now you're limited to 250 hours a month, which is a lot. All right. Another thing that we need to figure out as well is we need to keep a track of costs. Because you saw already I spent, what was it yesterday? Was it 85 euros or 81 euros I had on my, really? Yeah, because now it's saying, wait, little show it's saying now. Cost management. Where did I get, where was it where I could see what I've actually spent? Fuck it. Cost management, yeah. That. No, it's not that. Subscriptions. There was, click here. Let me just see. It was this morning I was doing it, so history. So 9:39 around this time. Create rule. Which one is it? Which one? Where did it say that? Up. 909. That's it. Thanks, sir. Yeah, one thing I don't like about it, it's not easy to find out what you spent or how to spend it. So this is the one. So one of the things I think needs to be figured out, are we sure it was 85 euros yesterday, was it?
Yeah.
Where did my €4 come from? That's it, yeah. So I click on usage here. That's what I'm saying. 1940. So it is fucking using something. How? I don't know what's being used. That's my problem. What is it? Yeah, unfortunately that doesn't work for us. Because the gobshite probably set us up with the wrong accounts. He should have set me up with a teacher's account and I could have managed them all. But no, he didn't do that. But it comes up now in a minute. Well, it eventually comes up. It's not the Azure classroom. See, he should have set up an Azure classroom for us, but he didn't, of course. Why would he do that? Because he's a dipshit. Okay, stop the video. Stop that now.